Good morning from another time and place. Sorry I couldn't be there in person or right now, but I do have some tips for everyone about using GitHub for collaborative programming. So why would we want to use GitHub for collaborative programming? Code readability decreases with time and distance. So right at the moment when you code something, or when you write something down, you know all the context of what you just did. But some other person is going to know less of the context than you do. And as time passes, you're going to lose a lot of that context in your own mind. Scope is hard to manage when you're working on a project of a reasonable amount of complexity. The scope will continue to grow. You'll find more bugs, you'll find more features, you'll find more nice to haves that there's always going to be more to do than there's time to do it in. It's necessary to prioritize which bugs are going to get fixed, which parts of the documentation are going to get beefed up, which features are going to be added now. What are the criteria for deciding to drop a feature? What are the criteria for deciding to deprecate some particular piece of code? Yeah, just resources are finite and code should do one thing and do it well. As projects are more complex, the shape of the project is malleable. And contributions to a project need to be trustworthy. Even renowned developers need to constantly develop in a way that's trustworthy. Using Git and GitHub helps with each of these issues. So what are we talking about when we're collaboratively programming with GitHub? We're using Git and GitHub specifically. Git is just a version control tool. GitHub uses Git and surrounds it with additional tools for communication and project management. There are competing products for each of these things. Things like Subversion instead of Git, things like GitLab or SourceHut or Bitbucket instead of GitHub. But most, if not all, of the projects here use Git and GitHub. How do we collaboratively program with GitHub? I've got a snippet here from the Zen of Python that is specifically Pythonic to do these things, but it applies generally in collaborative projects. Readability counts. Special cases aren't special enough to break the rules, although practicality beats purity. Giving some guidance here, these rules should be followed as much as is practical, but there will be times where it doesn't make sense to do one of these things. And if it doesn't make sense to do it, don't do it. For each commit, you want the subject line of the commit to be something short and clear. It should fit on one line. And then in the commit message, you can skip a line and add as much supplemental information as you want in there. But that's something that is not going to be seen very often. The first line is what you're going to see if you're looking at the history in Git or on GitHub, unless you're specifically digging into a particular commit. So just looking at a glance, this is all you're going to see. And the rule of thumb for writing a git commit subject line is to just fill in the blank. If applied, this commit will blank. In addition to filling in that blank, some projects use things like Gitmoji or conventional commits where you prepend or put in brackets something about the scope of the commit. So Gitmoji is a pseudo standard, so that you just have emoji down the left side of your history to see, like, this commit is fixing a bug, this commit is adding a feature, this commit is updating a test, this commit is upgrading a dependency, this commit is refactoring some code, this commit's just fixing a typo, this commit is moving files around. And so without even reading the commit messages, you can just see from the emoji what the kind of changes are in that commit. And so you can more quickly find the one that you're looking for. Conventional commits is a similar kind of thing, but that one is geared toward tooling around commits, so that if you want to automate a change log, that instead of manually writing your change log, you can use a conventional commits tool to find particularly tagged commits, like it gathers all the fixes into one place in the change log and all the new features into another place in the change log. Each of these work for some projects, they don't work for others, or they work for certain spans of time or certain branches of a project without being used consistently throughout the whole project. Do what works for your project, for your team. Likewise, there are probably infinite ways that you could structure a Git tree. Git flow and GitHub flow are the two most common, and the ones that you'll probably be working with. Git flow, you have a main branch, a development branch, and feature branches. The main branch has all the tested code that's released. The develop branch is where the upcoming releases are being built from, and the feature branches are what merge in to develop. Hotfixes merge back into main. Develop merges into main. CPAC is an example of a project that uses Git flow workflow. And you can see the main branch, the develop branch, and feature branches and hotfix branches in the network view on the GitHub Insights tab. GitHub flow is a simpler workflow. You just have feature branches come directly off the main branch, and pull requests from feature branches go straight back to the main branch. The repository for CPAC's documentation is an example of a project that uses GitHub flow. I mentioned earlier community health files, like a contributing guide, a README, license, code of conduct, and other documentation are also the places to start when orienting yourself to a project, or reorienting yourself if it's not one that you're involved in the day-to-day, because these things do change over time. And so when you are sporadically contributing to a project, you just want to brush up and see if anything's changed about how that project is being managed before diving in. Some of the features of GitHub that are particularly attractive and useful in tackling these problems: issues, pull requests, and discussions, which are all internally handled in much the same way on GitHub. It's something to get a little used to, a little oriented to, but once you do, it's easy to quickly move through them. issues, pull requests, and discussions. Issues are where you document scopes of work to be done, bug reports, feature requests, like future ideas, but they're actionable items. GitHub also has project boards with multiple views where issues are the size of units that move around on there, and the actual issues themselves are what you can put on the project board. You can also put pull requests and discussions on there. A pull request is structured like an issue, but it is where you are requesting that changes from a branch or fork are being pulled into an upstream branch or fork. So you have a feature branch that you've worked on. You would open a pull request to have those changes be reviewed before being merged back into your develop branch if you're using Git flow. If you're using GitHub flow, you would open a pull request into main. If you've got multiple branches that you're working on that are related, you might have one pull request going in to one branch, and then that branch has a pull request going into another branch, and so on in a cascade. The idea of the scope of a pull request is this is going to be larger than a commit usually, although sometimes it might be a single commit if the scope of the issue being addressed is that small. But the pull request generally is a series of commits that addresses a single issue. Depending on the project, something that is often useful is to open a pull request early and have active discussion before you're ready to merge it. And on GitHub, you have the option to open a draft pull request instead of a full pull request. And then once you think that it's ready to go, you can switch it from a draft request to one that's ready for review. These pull requests are where code review happens. It's open to anyone who has access to the repository. So don't feel like you need to be like a product manager or a code owner to comment on or review code in a pull request. Again, you also can comment on issues, but the pull requests in particular, it's good to see how other people on the team, what their coding style is, how that meshes with the existing code in the project. So you can get a feel for where there are different styles in the code base, what code is the legacy code that you're not wanting to emulate versus what the current team practices are that your style for that project should mesh with. And discussions are another similar scoped item on GitHub, and those are more open-ended things. So things that wouldn't fit as an issue because there's not a clear scope of work. It could be just a general question. In addition to those things, there will be things outside of GitHub that people will use. There's a lot of Slack, a lot of email, a lot of Google Docs. some Google groups. And these, again, will vary from project to project, time to time, team to team. What are the dangers of collaborative programming with GitHub? What if I mess something up? As long as what you were working on was committed, if what was working before was committed and then you broke it, there's nothing to worry about. That is, I think, the single best thing about a version control system is you can get back to any point in it. Git, for example, some commits from the develop branch got added in to a feature branch twice. So we have a duplicate string of commits that we'd like to get rid of from the feature branch so we can more clearly see what the actual changes are in this pull request. One option is to revert. Git as a revert command where it will take the changes from a commit or a string of commits and apply the reverse of those changes. So the errant commits are still in the history, and then there's a commit that shows where that was undone. Another option is rebase onto, where you can essentially cut out that string of commits by taking one commit and rebasing it on to another, skipping the ones in between. Or you can do an interactive rebase where you can just choose the specific commits you want to keep and choose the ones you want to drop. Another option would be to cherry pick commits if there were only a few. And in this case, there are only, I think, 5 or 6. So that could have been an option as well to start from this pre-double merge and start from here and then just cherry pick these 5 commits. Those are a handful of ways to resolve a Git error. There are countless other ways. Like most of the advice that I've been giving during this talk, how you would want to resolve an error will vary depending on the circumstances. There might be project-specific guidance. Some projects like strongly encourage rebasing. Some projects don't allow it. If you haven't pushed it yet and you rebase locally, nobody will ever know. What you push to the remote is all anybody else ever sees. But if you've already pushed to the remote and then you rebase, you'll have to force push to get those changes into the same branch name that you were using before, or you could rebase as a new branch and then continue your work from there, keeping the branch with the mistake or possible mistake with its original name in case it turns out that wasn't a mistake and you want to go back to that. It can be hard to find if you force push over it, but it does still exist. Git makes permanent irreversible changes hard to do by design. It's not impossible because if you accidentally upload a private key or a password or some other sensitive information to a public repository in particular, you do need to be able to delete some portion of the Git tree. But outside of that circumstance, you generally don't want to ever delete any portion of the Git tree. And so Git is designed in a way where it really takes some effort to permanently lose something. Depending on what kind of a mistake was made, there are a lot of different avenues for repair. So there are a lot of good resources, which I'll be talking about in an upcoming section of this talk. And that's also something that if a quick Google search doesn't seem to show up with what you're looking for, just ask on Slack, and somebody has, or on Stack Overflow, but somebody has for sure had the same problem before, and there's probably a pretty painless way to fix it. A caveat to that is if you haven't committed something that was working and then it stops working, Git doesn't have a way to get that back. The smaller the scope of commits and the smaller the scope of pull requests, the easier it is for other collaborators to review that code when you open a pull request, and the easier it is to make sense of in the future if we need to look back at it. In addition to the protections that Git has built in, GitHub has additional protections like branch protection rules to add even more friction to publishing unintentional changes. In Git, the metaphor for the changes is a tree, and the trunk is usually called main. They used to be called master, but the community was convinced that the language around slavery, that master is a potentially offensive term, and so they're typically called main now. So when you're digging into code bases, you'll see the main branch will be called main, but older ones it will be called master, and that's just an artifact of the history of the defaults. They can be named anything you'd like, and the commits are stored under an SHA hash that's a unique identifier for each change, each point in time. And a branch is a label for a sequence of commits. And specifically, a branch is a label for a commit in a sequence of commits, and each additional commit that is added in that branch, the branch name moves with those commits. A tag is similar to a branch, but it's a particular point in time. It's just an alias for an SHA. So those don't change unless they're overwritten or deleted and re-added. The idea being that branches are fluid, active development, and tags are references to what the code base was doing and able to do at a certain point in time. You can push your changes if they are just adding to the tree. You just push it, no problem, it goes up. If they conflict with changes that are in the remote tree, you can force push, in which case the branch name is moved from where it was pointed to where you pointed it to, but that doesn't remove the old branch from the tree. It could be hard to find, but it still exists. And the same thing with tags. If you overwrite a tag, that moves where the tag is pointing to, but it doesn't remove where the tag formerly pointed to. So those are recoverable kinds of errors. One thing that can be particularly intimidating when collaborating with Git is merge conflict resolutions can be nightmares. They happen when the same file is changed in two parallel branches and changed in ways that Git can't tell if those changes, um, like how those changes would interact with each other, what to keep from column A and what to keep from column B. There are a lot of tools that you can use. You find one that works for you. Meld is my absolute favorite. The screenshot here is just from their webpage. But in addition to this like A, B column, Meld also has a 3-column view where you have the changes from one branch on the left, the changes from the other branch on the right, and then in the middle, what you want to keep. And so you can dynamically decide which lines from which branch you want to keep, and sometimes resolving a merge conflict actually involves making some changes that don't exist in either branch to make those changes work together. Like, for example, if each parallel branch added a function with the same name but different purposes, you'd have to rename one or both of those functions in the conflict resolution. If you need help while you're collaboratively programming with GitHub, the official Git documentation is fantastic. Git is powerful, but it's also pretty simple and pretty mature. So the documentation is fairly comprehensive. And there's a book called Pro Git that is available in a digital form for free on the Git website. And Git itself, just on your machine, has like a little cheat sheet that you can get to by saying git space help space every day. And Git also comes packaged with a set of guides and tutorials, which you can see by saying git space help space -G, and that will list out the commands the names of the various tutorials. And if you want to go into one, you say git space help space that name. GitHub also has pretty thorough documentation. Unlike Git, GitHub is constantly adding and changing features, so its comprehensiveness is not as full as Git's. Git is also an active project, but its core functionality is very stable. And the new features that are added for it are typically more things for dealing with efficiency and like developer experience. There's a new feature that's pretty recent in Git within the last couple of minor versions where you can open a web page from the command line. It'll open a web page where you can browse the Git history. Those kinds of features, they're like bells and whistles is what Git itself is adding. But GitHub has a lot broader mandate than Git. Git is strictly version control. GitHub is communication and project management. And so GitHub is wanting to compete with Slack and with Monday and with all of the Atlassian tools, like with Trello and with Basecamp. And so they're constantly adding features, testing things out, deprioritizing, reprioritizing, clones of and improvements of or variations of features that you'll find in other project management software. GitHub stays pretty closely tied to managing code, but not strictly. But they do a very good job of publicly documenting all these changes that they're making. Your team is also an excellent resource. Last April, we had a little internal Q&A session about this very topic, about using Git and GitHub collaboratively. And so in addition to the links that I covered here today, I'll also share the minutes from that meeting last April. It is filled with resources and questions and comments related to the things I talked about here, and some related things like visualization, additional features, setting up your profile on GitHub. On GitHub, you have the option for your user and for any organizations that you're a part of to make a special profile repository. And then this repository shows up on the profile page for that user or organization. It's a good place to give personal or organizational like baseline information that applies at all times, like working hours, time zone, whatever you want people to know immediately before interacting with you on GitHub or before interacting with your organization on GitHub. And GitHub also has special .github directory that you can include in any repository, where you can make templates for issues or for pull requests, for discussions. You can put community health files in there. Also, a place where you can set configurations for Dependabot, which is a bot on GitHub that keeps an eye on the dependencies of a project, and especially with an eye on security releases. So when a security issue is publicized and a patch is released, Dependabot can open a PR for you. And you can configure like how often, and if you want it to do those in batches or per dependency. And you can also set up workflows for GitHub Actions for automation, which is what I will be talking about live, but still over video later in the week.